Hey, I'm back. I'm just going to give you a little, some pointers on how to do this protein synthesis race. It's not a race, but try to get it done. It's got to be done before the end of the semester. Well, it's got to be done by what, Friday? So, anyways, all right. So you're going to click on this. Boink. It's going to take you to this Bioman protein synthesis race. You're going to click Start a New Game. And look, you should want to read this. Transcription is the copying of a gene, which is a segment of DNA. Hey, then you come here and you can say, hey, transcription is the copying of a gene, which is a section of DNA. And then all the answers are going to come from this program. But I'm going to show you how it works. All right, I get it. So I'm not going to read all this junk because I already know the answers. But when you're doing this, you're going to want to read it. Notice that the DNA molecule has unzipped. So it's got to unzip before it can make a messenger RNA. Only one strand is used for transcription. We're going to use the top strand. Click on it. All right, click. Boom. An enzyme called Rna Polymerase is used to add RNA nucleotides. You won't have to know Rna Polymerase. Click on them, but you're going to have to be able to click on them. All right, good. Now, RNA polymerase is ready to add new nucleotides. RNA polymerase is touching the first nucleotide of the DNA sequence. Find the RNA nucleotide that is complementary. So it's touching a T. T goes with A. I'm going to click A. And it's going to take this. Look at it. It's really long. So I'm going to go fast. Okay, I get it. Next one's an A. A goes with U. C goes with G. A goes with U. G goes with C. T, T, A, A. A. A goes with U. C goes with G. A goes with U. G goes with C. T, 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 A. C goes with G. T goes with A. G, G goes with C, C. C goes with G. 4 T's in a row, 4 A's in a row. C, G, T, A. G, G goes with C, C. We're making a messenger RNA here by copying the code in DNA. C goes with G. T goes with A. A goes with U, because remember, there's no T in RNA. G goes with C. TT will be A. A goes with U. C goes with G. TTT will be A. A goes with U. C goes with G. And last but not least, T goes with A. Voila, we got our messenger RNA. I get it. Now the DNA can zip back up. So DNA is going to zip back up after the messenger RNA takes off. I get it. Click on the messenger RNA. So I'm going to click on it. Boink. Look, and then it tells me what to do. Down. So I put my down arrow on my keyboard. You go down. Now it goes right. Go this way. All right. The messenger RNA is leaving. It's going to a ribosome because that's where proteins are made. Now it has the code of DNA and it's headed to a ribosome. That was transcription. Now look, the DNA is going to re-zip. It's going to go back together to being double-sided again. And doink. All right, now I'm ready. Did you get it? Yes, I got it. Oh, man. DNA and RNA are called nucleotides. Doink. What is the name of the enzyme? RNA polymerase. Boink. Boink. How many strands of DNA have? 2. Boink. Boink. How many RNA? 1. Boink. Boink. Which RNA nucleotide is complementary to guanine? Cytosine. G always goes with C. Which is complementary to adenine? Well, in DNA, it'd be thymine or T, but in RNA, it's uracil or U. Which RNA nucleotide is complementary to thymine? It's still adenine. Boink. What's the function of mRNA? Both A and C. Doink. What happens to DNA once transcription is done? It zips back up. Doink. All right, good. I'm just going to skip, and I'm going to go to the next level. All right, so now it says use the arrow keys to transport mRNA to where it needs to go. It needs to go to the ribosome, this little dot out here. So I'm going to get them out of the nucleus. This is where mRNA leaves the nucleus. Go through that little pore. Go up a little bit. Head to the ribosome. Dink. All right, I made it. And now here's the second step of protein synthesis, translation. All right, in order to understand translation, you must understand that a protein is a chain of amino acids. It's a chain of amino acids. It's the order of the amino acids and the length of the chain that determine what kind of protein it will be. Okay, I get it. You must also understand that mRNA carries the instructions. mRNA is down here. It's this big long thing right down here. That's messenger RNA. To make a protein, a codon is a triplet. It's 3 bases in a row. So the first codon is A, U, G. The next one is U, C, A. 3 bases or 3 letters on an mRNA makes a codon. So each codon codes for a specific amino acid. For instance, the codon AUG codes for the amino acid methionine. So look, you can see right here, up here in this little mini codon chart, AUG codes for methionine, and methionine is a blue little ball. Serine is red, lysine is yellow, asparagine is pink, arginine is white, and stop. All right, so you can see here are the tRNAs up here, and they have the anticodons. I get it. Look at the mRNA. The first codon is located in the P site. You won't need to know the P site. What is the first codon? Click on it. I'm going to click on it. It's AUG. Doink. Clicked on it. Find the tRNA with the complementary anticodon. So AUG. AUG is going to go with UAC. So I need to find, and this right here, UAC. I'm going to click on this guy. Doink. Now you can move the selected tRNA with the arrow keys. So now I can move that guy. So now I can move him around. That's the tRNA. But look, he doesn't have an amino acid. I need to get an amino acid. And for AUG, it's going to be methionine. It's going to be a blue ball. I get it. All right, so I need to find a blue ball. There it is. I see a blue one. Boink, I got it. Now I take the UAC, and it's going to match up with the AUG. Because, stop moving. There we go. Because A goes with U goes with A, C goes with G. Boink. There we go. Now we're going to keep matching up codons with anticodons. The next codon is UCA. UCA codes for serine or red. Now, what anticodon would go with UCA? Well, U would go with A, C goes with G, A goes with U. So I need AGU. And here it is. Here's AGU. And now I got to get a red serine amino acid. Boom, I got it. Take it down. A goes with U, G goes with C, U goes with A. Doink! Look, now we got 2 amino acids. We're making a protein. The next one is AUG again. Remember, AUG, I need to get a blue methionine little amino acid. I got this guy. I get a blue one. Let's get a blue one, and I got it. Down I go. And here it is. It's going to match up the anticodon. It's going to match up with the codon. U goes with A goes with U, C goes with G. Doink. Now we got 3. 1, 2, 3. I'll do one more. The next codon is UCA. UCA codes for serine again. UCA, so I need a red one. And I need this guy because UCA goes with AGU. Doink. So I need to get this guy again. I need to get a red serine. Doink. Got it. Down I go again. And the A is going to go with the U, the G is going to go with the C, and the U is going to go with the A, and doink. Now we got 1, 2, 3, 4 amino acids. Now keep going. The next one's AAA. I'll do one more. What the heck? AAA stands for or codes for lysine. That's an orange one. AAA, obviously, the anticodon on tRNA is going to be UUU. So I'm going to click on this guy, and now I can move him. Now I got to get an orange one. Boom, I got it. Now I go down. I'm going to match up anticodon on the tRNA, this red thing, with the codon on the mRNA, and boink. Now it's 1, 2, 3, 4, 5 amino acids long. This is the process. This is translation of building a protein or a string of amino acids together to form a protein. So keep going. You're all the way to the end until you reach the stop. Stop is not an amino acid. That just means protein synthesis is done and that protein is ready to do its job. All right, so keep going all the way to the end. Answer all the questions. If you have any trouble, ask your partners. Do this with partners, or you can wait for me to help you on Friday. All right, so just do your best, and I'll see you on Friday.